In this chapter, we're going to cover streaming and async in LangChain. Now, both using async code and using streaming are incredibly important components of, I think, almost any conversational chat interface, or at least any good conversational chat interface. For async, if your application is not async and you're spending a load of time in your API or whatever else waiting for LLM calls, because a lot of those are behind APIs, you are waiting and your application is doing nothing because you've written synchronous code. And that, well, there are many problems with that. Mainly, it doesn't scale. So async code generally performs much better, and especially for AI, where a lot of the time we're kind of waiting for API calls. So async is incredibly important for that. For streaming, now streaming is a slightly different thing. So let's say I want to tell me a story. Okay, I'm using GPT-4 here. It's a bit slower, so we can actually use streaming. We can see that token by token, this text is being produced and sent to us. Now, this is not just a visual thing. This is the LLM. When it is generating tokens or words, it is generating them one by one. And that's because these LLMs literally generate tokens one by one. So they're looking at all of the previous tokens in order to generate the next one, and then generate next one, generate next one. Now, that's how they work. So when we are implementing streaming, we're getting that feed of tokens directly from the LLM through to our back end or our front end. That is what we see when we see that token by token interface. All right, so that's one thing. But one other thing that I can do, let me switch across to 4.0, is I can say, okay, we just got this story. I'm going to ask, are there any standard storytelling techniques to follow, use above? Please use search. Okay, so look, we get this very briefly there. We saw that it was searching the web. And the way, it's not because we told it, okay, we told the LLM to use the search tool, but then the LLM output some tokens to say, use the search tool, that it's going to use a search tool. And it also would have output the tokens saying what that search query would have been, although we didn't see it there. But what the ChatGPT interface is doing there, so it received those tokens saying, hey, I'm going to use a search tool. It didn't just send us those tokens like it does with the standard tokens here. Instead, it used those tokens to show us that searching the web little text box. So streaming is not just the streaming of these direct tokens, it's also the streaming of these intermediate steps that the LLM may be thinking through, which is particularly important when it comes to agents and agentic interfaces. So it's also a feature thing, right? Streaming doesn't just look nice, it's also a feature. Then finally, of course, when we're looking at this, okay, let's say we go back to GPT-4 and I say, okay, use all of this information to generate a long story for me, right? And okay, we are getting the first token now. So we know something is happening and we need to start reading. Now imagine if we were not streaming anything here and we're just waiting, right? We're still waiting now. We're still waiting. And we wouldn't see anything. We're just like, oh, it's just blank, or maybe there's a little loading spinner. So we'd still be waiting. And even now, we're still waiting, right? This is an extreme example, but can you imagine just waiting for so long and not seeing anything as a user, right? Now, just now, we would have got our answer if we were not streaming. I mean, that would be painful as a user. You'd not want to wait, especially in a chat interface. You don't want to wait that long. It's okay with, for example, deep research takes a long time to process. But it's going to take a long time to process, and it's a different use case, right? You're getting a report. this is a chat interface. And yes, most messages are not going to take that long to generate. We're also probably not going to be using GPT-4, depending on, I don't know, maybe some people still do. But in some scenarios, it's painful to need to wait that long. Okay. And it's also the same for agents. It's nice when you're using agents to get an update on, okay, we're using this tool, it's using this tool, this is how it's using them. Perplexity, for example, have a very nice example of this. So, okay, what's this? OpenAI co-founder joins Marathi startup. Let's see, right? So we see this is really nice. We're using Pro Search. It's searching for news, showing us the results. Like we're getting all this information as we're waiting, which is really cool. And it helps us understand what is actually happening, right? It's not needed in all use cases, but it's super nice to have those intermediate steps, right? So then we're not waiting. And then I think this bit probably also streamed, but it was just super fast. So I didn't see it, but that's pretty cool. So streaming is pretty important. Let's dive into our example. Okay, we'll open that in Colab and off we go. So starting with the prerequisites, same as always, LangChain, optionally Langsmith. We'll also enter our LangChain API key if you'd like to use Langsmith. We'll also enter our OpenAI API key. So that is platform.openai.com. And then as usual, we can just invoke our LLM, right? So we have that, it's working. Now let's see how we would stream with a stream. Okay, so whenever a method, so stream is actually a method as well, we could use that, but it's not async, right? So whenever we see a method in LangChain that has a prefixed onto what would be another method, that's like the async version of this. So we can actually stream using async super easily using just LLM a stream. Okay. Now, this is just an example. To be completely honest, you probably will not be able to use this in an actual application, but it's just an example. And we're going to see how we would use this or how we would stream asynchronously in an application further down in this notebook. So starting with this, you can see here that we're getting these tokens, right? We're just appending it to tokens here. We don't actually need to do that. I don't think we're even using this, but maybe we'll do it here. It's fine. So we're just appending the tokens as they come back from our LLM, appending it to this. We'll see what that is in a moment. And then I'm just printing the token content, right? So the content of the token. So in this case, that would be L. In this case, it would be LP. Would be sans for so on and so on. So you can see for the most part, it tends to be word level, but it can also be subword level. As you see, sentiment is one word, of course. So, they get broken up in various ways. Then I'm adding this pipe character onto the end here. So we can see, okay, where are our individual tokens? Then we also have flush. So flush, you can actually turn this off and it's still going to stream. You're still going to see everything, but it's going to be a bit more, you can see it's kind of it's like bit by bit. When we use flush, it forces the console to update what is being shown to us immediately. All right, so we get a much smoother, when we're looking at this, it's much smoother versus when flush is not set to true. So yeah, when you're printing, that is good to do just so you can see. You don't necessarily need to. Okay. Now we added all those tokens to the tokens list so we can have a look at each individual object that was returned to us, right? And this is interesting. So you see that we have the AI message chunk, right? That's an object. And then you have the content. The first one's actually empty. Second one has that N for NLP. And yeah, I mean, that's all we really need to know. They're very simple objects, but they're actually quite useful because just look at this, right? So we can add each one of our AI message chunks, right? Let's see what that does. It doesn't create a list. It creates this, right? So we still just have one AI message chunk, but it's combined the content within those AI message chunks, which is kind of cool, right? So for example, like we could remove these, right? And then we just see NLP. So it's kind of nice little feature there. I actually quite like that. But you do need to just be a little bit careful, because obviously you can do that the wrong way and you're going to get like I don't know what that is, some weird token salad. So yeah, you need to just make sure you are going to be merging those in the correct order, unless you're doing something weird. Okay, cool. So streaming, that was streaming from a LLM. Let's have a look at streaming with agents. So it gets a bit more complicated, to be completely honest. But we also need things are going to get a bit more complicated so that we can implement this in, for example, an API, right? So it's kind of like a necessary thing in any case. So to just very quickly, we're going to construct our agent executor like we did in the agent execution chapter. And for the agent executor, we're going to need tools, chat prompt template, LLM, agent, and the agent executor itself. Okay. Very quickly, I'm not going to go through these in detail. We just define our tools. We have add, multiply, exponentiate, subtract, and the final answer tool. Merge those into a single list of tools. Then we have our prompt template. Again, same as before, we just have system message, we have chat history, we have query, and then we have the agent scratchpad for those intermediate steps. Then we define our agent using LCell. LCell works quite well with both streaming and async, by the way. It supports both out of the box, which is nice. So we define our agent. Then coming down here, we're going to create the agent executor. This is the same as before, right? So there's nothing new in here, I don't think. So just initialize our agent things there. Then it's, we're looping through, yeah, nothing new there. So we're just executing, we're invoking our agent, seeing if there's a tool call. This is we could shift this to before or after. It doesn't actually matter that much. So we're checking if it's final answer. If not, we continue, execute our tools, and so on. Okay, cool. So then we can invoke that. Okay, we go, what is 10 plus 10? There we go, right? So we have our agent executor. It is working. Now, when we are running our agent executor, with every new query, if we're putting this into an API, we're probably going to need to provide it with a fresh callback handler. Okay, so this is the callback handler is what's going to handle taking the tokens that are being generated by our LLM or agent and giving them to some other piece of code, like, for example, the streaming response for a API. And our callback handler is going to put those tokens in a queue in our case. And then for example, the streaming object is going to pick them up from the queue and put them wherever they need to be. So to allow us to do that with every new query, rather than us needing to initialize everything when we actually initialize our agent, we can add a configurable field to our LLM. Okay, so we set the configurable fields here. Oh, also one thing is that we set streaming equal to true. That's a very minor thing, but just so you see that there, that we do that. So we add some configurable fields to our LLM, which means we can basically pass an object in for these on every new invocation. So we set our configurable field. It's going to be called callbacks, and we just add a description, right? There's nothing more to it. So this will now allow us to provide that field when we're invoking our agent. Okay. Now we need to define our callback handler. And as I mentioned, what is basically going to be happening is this callback handler is going to be passing tokens into our async IO queue object, and then we're going to be picking them up from the queue elsewhere. Okay, so we can call it a queue callback handler. Okay, and that is inheriting from the async callback handler, because we want all this to be done asynchronously, because we're thinking here about, okay, how do we implement all this stuff within APIs and actual real world code? And we do want to be doing all this in async. So let me execute that, and I'll just explain a little bit of what we're looking at. So we have the initialization, right? There's nothing specific here. We just what we really want to be doing is we want to be setting our queue object, assigning that to the class attributes. And then there's also this final answer seen, which we're setting to false. So what we're going to be using that for is our LLM will be streaming tokens to us whilst it's using its tool calling. And we might not want to display those immediately, or we might want to display them in a different way. So by setting this final answer seen to false, whilst our LLM is outputting those tool tokens, we can handle them in a different way. And then as soon as we see that it's done with the tool calls and it's onto the final answer, which is actually another tool call, but once we see that it's onto the final answer tool call, we can set this to true, and then we can start processing our tokens in a different way, essentially. Okay, so we have that. Then we have this AITER method. This is required for any async generator object. So what that is going to be doing is going to be iterating through, right? So it's a generator. It's going to be iterating through, and it's going to be saying, okay, if our queue is empty, right? This is the queue that we set up here. If it is empty, wait a moment, right? We use the sleep method here. And this is an async sleep method. This is super important. We're awaiting for an asynchronous sleep. All right. So whilst we're waiting for that 0.1 seconds, our code can be doing other things, right? That is important. If we use, I think the standard is time.sleep, that is not asynchronous. And so it will actually block the thread for that 0.1 seconds. So we don't want that to happen. Generally, our queue should probably not be empty that frequently, given how quickly tokens are going to be added to the queue. So the only way that this would potentially be empty is maybe our LLM stops. Maybe there's like a connection interruption for a brief second or something, and no tokens are added. So in that case, we don't actually do anything. We don't keep checking the queue. We just wait a moment, okay? And then we check again. Now, if it was empty, we wait, and then we continue on to the next iteration. Otherwise, it probably won't be empty. We get whatever is from inside our queue. We get that out, pull it out. Then we say, okay, if that token is a done token, we're going to return. So we're going to stop this generator, right? We're finished. Otherwise, if it's something else, we're going to yield that token, which means we're returning that token, but then we're continuing through that loop again, right? So that is our generator logic. Then we have some other methods here. These are LangChain specific. Okay, we have on LLM new token, and we have on LLM end. Starting with on LLM new token. This is basically when an LLM returns a token to us. LangChain is going to run or execute this method. Okay, this is the method that will be called. What this is going to do is it's going to go into the keyword arguments, and it's going to get the chunk object. So this is coming from our LLM. If there is something in that chunk, it's going to check for a final answer tool call first. Okay, so we get our tool calls, and we say if the name within our chunk, right? Probably this will be empty most of the tokens we return. Right, so you remember before when we're looking at the chunks here, this is what we're looking at, right? The content for us is actually always going to be empty, and instead we're actually going to get the additional keyword args here, and inside there we're going to have our tool calls as we saw in the previous videos, right? So that's what we're extracting. We're extracting that information. That's why we're going additional keyword args, right, and get those tool call information, right? Or it will be none, right? So if it is none, I don't think it ever would be none, to be honest. It would be strange if it's none. I think that means something would be wrong. Okay, so here we're using the walrus operator. So the walrus operator, what it's doing here is whilst we're checking the if logic here, whilst we do that, it's also assigning whatever is inside this, it's assigning over to tool calls. And then with the if, we're checking whether tool calls is something or none, right? Because we're using get here. So if this get operation fails and there is no tool calls, this object here will be equal to none, which gets assigned to tool calls here. And then this if none will return false, and this logic will not run, okay? And it will just continue. If this is true, so if there is something returned here, we're going to check if that something returned is using the function name or tool name final answer. If it is, we're going to set that final answer C equal to true. Otherwise, we're just going to add our chunk into the queue. Okay, we use put no wait here because we're using async. Otherwise, if you were not using async, I think you might just put wait, or maybe even put. No, okay, you'd use put if it's just synchronous code. But I don't think I've ever implemented this synchronously, so it would actually just be put no wait for async. Okay, and then return. So we have that. Then we have on LLM end. Okay, so this is when LangChain sees that the LLM has returned or indicated that it is finished with the response, LangChain will call this. So you have to be aware that this will happen multiple times during an agent execution, because if you think within our agent executor, we're hitting the LLM multiple times. We have that first step where it's deciding, oh, I'm going to use the add tool or the multiply tool. And then that response gets back to us. We execute that tool, and then we pass the output from that tool and or the original user query in the chat history, we pass that back to our LLM again. All right, so that's another call to our LLM that's going to come back, it's going to finish, or it's going to give us something else, right? So there's multiple LLM calls happening throughout our agent execution logic. So this on LLM call will actually get called at the end of every single one of those LLM calls. Now, if we get to the end of our LLM call, and it was just a tool invocation, so we had it called the add tool, we don't want to put the done token into our queue, because when the done token is added to our queue, we're going to stop iterating, okay? Instead, if it was just a tool call, we're going to say step end, right? And we'll actually get this token back. So this is useful on, for example, the front end. You could have, okay, I've used the add tool. These are the parameters, and it's the end of the step. So you could have that your tool call is being used on some front end, and then as soon as it sees step end, it knows, okay, we're done with that. Here was the response, right? And it can just show you that. And we're going to use that. We'll see that soon. But let's say we get to the final answer tool. We're on the final answer tool, and then we get this signal that the LLM has finished. Then we need to stop iterating. Otherwise, our streaming generator is just going to keep going forever, right? Nothing's going to stop it. Or maybe it will time out. I don't think it will, though. So at that point, we need to send, okay, stop, right? We need to say we're done. And then that will come back to here, to our A iterator and to our async iterator, and it will return and stop the generator, okay? So that's the core logic that we have inside there. I know there's a lot going on there. But we need all of this, so it's important to be aware of it. Okay, so now let's see how we might actually call our agent with all of this streaming in this way. So we're going to initialize our queue, and we're going to use that to initialize a streamer, okay, using the custom streamer that we just set up, custom callback handler, whatever you want to call it, okay? Then I'm going to define a function. So this is an asynchronous function. It has to be if we're using async. And what it's going to do is it's going to call our agent with a config here, and we're going to pass it that call, the callback, which is the streamer, right? Note here, I'm not calling the agent executor. I'm just calling the agent, right? So if we come back up here, we're calling this, all right? So that's not going to include all the tool execution logic. And importantly, we're calling the agent with the config that uses callbacks, right? So this configurable field here from our LLM is actually being fed through, and it propagates through to our agent object as well, to the runnable serializable. All right, so that's what we're executing here. We see agent with config, and we're passing in those callbacks, which is just one actually. Okay, so that sets up our agent, and then we invoke it with a stream, okay, like we did before. And we're just going to return everything. So let's run that. Okay, and we see all the token or the chunk objects that are being returned. And this is useful to understand what we're actually doing up here. Right, so when we're doing this chunk message, additional keyword arguments, right, we can see that in here. So this would be the chunk message object. We get the additional keyword args, we go into tool calls, and we get the information here. So we have the ID for that tool call, as we saw in the previous chapters. Then we have our function, right? So the function includes the name, right? So we know what tool we're calling from this first chunk, but we don't know the arguments, right? Those arguments are going to be streamed to us. So we can see them begin to come through in the next chunk. So the next chunk is just a first token for the add function, right? And we can see these all come together over multiple steps, and we actually get all of our arguments. Okay, that's pretty cool. So actually, one thing I would like to show you here as well. So if we just do token equals tokens, sorry, and we do tokens.append token. Okay, we have all of our tokens in here now. All right, see that they're all AI message chunks. So we can actually add those together. All right, so we'll go with these here. And based on these, we're going to get all the arguments. Okay, so this is kind of interesting. So it's 1 until I think like the second to last, maybe. Right, so we have these. And actually, we just want to add those together. So I'm going to go with tokens 1. I'm just going to go for token in. We're going to go from the second onwards. I'm going to TK plus token. Right, and let's see what TK looks like at the end here. TK. Okay, so now you see that it's kind of merged with all those arguments here. Sorry, plus equal. Okay, so run that, and you can see here that it's merged those arguments. It didn't get all of them, so I kind of missed some at the end there. But it's merging them, right? So we can see that logic where it's, before it was adding the content from various chunks, it also does the same for the other parameters within your chunk object, which is I think it's pretty cool. And you can see here the name wasn't included. That's because we started on token 1 rather than token 0 where the name was. So if we actually started from token 0, and let's just put all of them in there. All right, so from 1 onwards, we're going to get a complete AI message chunk, which includes the name here and all of those arguments. And you'll see it also here, right? Populate everything, which is pretty cool. Okay, so we have that. Now, based on this, we're going to want to modify our custom agent executor because we're streaming everything, right? So we want to add streaming inside our agent executor, which we're doing here, right? So this is async def stream, and we're doing async for token in the A stream, okay? So this is like the very first instance. If output is none, we're just going to be adding our token, so the chunk, to our output, like the first token becomes our output. Otherwise, we're just appending our tokens to the output, okay? If the token content is empty, which it should be, right, because we're using tool calls all the time, we're just going to print content, okay? I just added these so we see, like, print everything. I just want to be able to see that. I wouldn't expect this to run because we're saying it has to use tool calling, okay? So within our agent, if we come up to here, we said tool choice any, so it's been forced to use tool calling. So it should never really be returning anything inside the content field. But just in case, it's there, right? So we'll see if that is actually true. Then we're just getting out our tool calls information, okay, from our chunk. And we're going to say, okay, if there's something in there, we're going to print what is in there, okay? And then we're going to extract our tool name. If there is a tool name, I'm going to show you the tool name. Then we're going to get the args, and if the args are not empty, we're going to see what we get in there, okay? And then from all of this, we're actually going to merge all of it into our AI message, right? Because we're merging everything as we're going through, we're merging everything into outputs, as I showed you before. Okay, cool. And then we're just awaiting our stream that will like kick it off. Okay, and then we do the standard agent executor stuff again here, right? So we're just pulling out tool name, tool logs, tool call ID, and then we're using all that to execute our tool here. And then we're creating a new tool message and passing that back in. And then also here, I move the break for the final answer into the final step. So that is our custom agent executor with streaming. And let's see what it does. Okay. Setting for both equal to true, so we see all those print statements. Okay. So you can kind of see it's a little bit messy, but you can see we have tool calls that had some stuff inside it, had add here. And what we're printing out here is we're printing out the full AI message chunk with tool calls. And then I'm just printing out, okay, what are we actually pulling out from that? So these are actually coming from the same thing, okay? And then the same here, right? So we're looking at the full message, and then we're looking, okay, we're getting this argument out from it, okay? So we can see everything that is being pulled out, chunk by chunk, or token by token, and that's it, okay? So we could just get everything like that. However, right, so I'm printing everything so we can see that it's streaming. What if I don't print? Okay, so we're setting verbose, or by default verbose is equal to false here. So what happens if we invoke now? Let's see. Okay. Cool. We got nothing. So the reason we got nothing is because we're not printing. But we don't, if you're building an API, for example, you're pulling your tokens through, you can't print them to your, like a front end, or print them as to the output of your API. Printing goes to your terminal, right? Your console window. It doesn't go anywhere else. Instead, what we want to do is we actually want to get those tokens out, right? But how do we do that? All right. So we printed them, but another place that those tokens are is in our queue, all right? Because we set them up to go to the queue. So we can actually pull them out of our queue whilst our agent executor is running, and then we can do whatever we want with them because our code is async. So it can be doing multiple things at the same time. So whilst our code is running the agent executor, whilst that is happening, our code can also be pulling out from our queue tokens that are in there and sending them to like an API, for example, right? Or whatever downstream logic you have. So let's see what that looks like. We start by just initializing our queue, initializing our streamer with that queue. Then we create a task. So this is basically saying, okay, I want to run this, but don't run it right now. I'm not ready yet. The reason that I say I'm not ready yet is because I also want to define here my async loop, which is going to be printing those tokens, right? But this is async, right? So we set this up. This is like, get ready to run this. Because it is async, this is running, right? This is just running. Like it's there, it's already running. So we get to this, we continue. None of this is actually executed yet, right? Only here, when we await the task that we set up here, only then does our agent executor run and our async object here begin getting tokens, right? And here, again, I'm printing, but I don't need to print. I could have like a, let's say where this is within an API or something. Let's say I'm saying, okay, send token to XYZ token, right? That's sending up tokens somewhere. Or if we're yielding this to some sort of streamer object within our API, right? We can do whatever we want with those tokens. Okay, I'm just printing them because I want to actually see them. Okay, but just important here is that we're not printing them within our agent executor. We're printing them outside the agent executor. We've got them out and we can put them wherever we want, which is perfect when you're building an actual sort of real world use case where you're using an API or something else. Okay, so let's run that. Let's see what we get. look at that. We get all of the information we could need and a little bit more, right? Because now we're using the agent executor, and now we can also see, oh, we have this step end, right? So I know, or I know just from looking at this, right? This is my first tool use. So what tool is it? Let's have a look. It's the add tool. And then we have these arguments, so I can then pass them, right, downstream. Then we have the next tool use, which is here, down here. So then we can then pass them in the way that we like. So that's pretty cool. Let's see, right? So we're getting those tokens out. Can we do something with them before I print them and show them? Yes. Let's see. Okay. So we're now modifying our loop here. Same stuff, right? We're still initializing our queue, initializing our streamer, initializing our tasks. Okay. And we're still doing this async for token streamer. Okay. But then we're doing stuff with our tokens. So I'm saying, okay, if we're on stream end, I'm not actually going to print stream end. I'm going to print new line. Okay. Otherwise, if we're getting a tool call here, we're going to say, if that tool call is the tool name, I am going to print calling tool name. Okay. If it's the arguments, I'm going to print the tool argument, and I'm going to end up with nothing so that we don't go into a new line. So we're actually going to be streaming everything. Okay. So let's just see what this looks like. Oh, my bad. I just added that. Okay. You see that? So it goes very fast, so it's kind of hard to see it. I'm going to slow it down so you can see. So you can see that as soon as we get the tool name, we stream that we're calling the add tool. Then we stream token by token, the actual arguments for that tool. Then for the next one, again, we do the same. We're calling this tool name. Then we're streaming token by token again. We're processing everything downstream from outside of the agent executor. And this is an essential thing to be able to do when we're actually implementing streaming and async and everything else in an actual application. So I know that's a lot, but it's important. So that is it for our chapter on streaming and async. I hope it's all been useful. Thanks.